Welcome to the House That STEM Built, a regular series where we will explore the science, technology, engineering, and math that goes into the design and construction of this family home. This is the House That STEM Built.
Hi, this is Jenna.
And Molly.
Welcome to the House That STEM Built.
In this video, we will relate the Pythagorean Theorem to the building of this home and address these specific curriculum outcomes. G2. Demonstrate an understanding of the Pythagorean Theorem by identifying situations that involve right triangles, verifying the formula, applying the formula, and solving problems. And A1. Solve problems that require the application of formulas related to the Pythagorean Theorem, all from the grade 10 math unit on geometry, measurements, and finance. What is Pythagorean Theorem, you might ask? Well, over 2,000 years ago in ancient Greece, there was an amazing discovery made about triangles. The discovery was made by a man named Pythagoras.
The Pythagorean Theorem describes an important geometric relationship between the three sides of a right-angled triangle. Before learning about Pythagorean Theorem, you should already have background knowledge of squares, square roots, and basic algebra.
All right, assuming you know the basic knowledge, let's get into the actual theorem. Pythagoras discovered that when a triangle has a right angle, or 90 degrees, and squares are made on each of the three sides, then the biggest side has the exact same area as the other two squares put together. How do we identify right triangles? Well, they have a 90-degree angle as well as the long side of the triangle, which is the opposite of the 90-degree angle. We call this the hypotenuse. In other words, it is the side that does not touch or help form the 90-degree angle. C will always be the longest side, or the hypotenuse, of the triangle. And A and B are the shorter two sides and can be used interchangeably.
This theorem is represented by the following formula. A squared plus B squared equals C squared. Therefore, the official definition is, in a right-angled triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides.
All right, Jenna, so how did we use the Pythagorean Theorem to build a house? Well, you may not realize it, but math is everywhere. From what we just learned, we know that the Pythagorean Theorem is used anytime there's a right-angled triangle. When do you think right angles were used when building the house?
What about the stairs, or the roof, the slanted ceilings, or even doorways? The theorem allows us to find the length of the missing side of a right-angled triangle. By using the equation a squared plus b squared equals c squared, we can find the missing side of any right-angled triangle used during the construction of the house.
Let's take a look at some places we needed to use this theorem throughout the building of this home.
Let's take a look at these stairs. When building the house, the carpenters knew the stairs had to be 3 meters tall. We'll call this side A. And 4 meters long. Let's call this side B. The carpenters wanted to know the length of the actual stairs, which is the length of the hypotenuse, which we call side C. This problem can be solved using the Pythagorean Theorem.
All right, let's put our formula to work. We know that the formula is a squared plus b squared equals c squared. Therefore, if we substitute in the values, we have 3 squared plus 4 squared equals c squared, or our unknown length of the hypotenuse. From our background knowledge of exponents, we know that 3 squared equals 3 times 3. 4 squared equals 4 multiplied by 4. Since 3 multiplied by 3 is equal to 9, and 4 times 4 equals 16, when we add them together, we get 25. So, 9 plus 16 equals c squared, or 25. To solve for c, we must take the square root of both sides of the equation. Taking the square root of c squared leaves us with c, and taking the square root of 25 results in 5. So now we know that c, which represents the length of the hypotenuse, is 5 meters.
Amazing how we can use math in building a house. Let's look at another example. Where can we find another right angle triangle? I know, Molly. The roof.
In this example, the hypotenuse, or c, is 4 meters in length. And our side A, or the length of the roof, is approximately 2.8 meters, so we need to determine side B, or the height of the roof. To do this, we need to use Pythagorean equation again, but this time in a slightly different way. If we look at the equation, a squared plus b squared equals c squared, we can see that the equation is not set up to solve for the unknown variable b. By using a bit of algebra, we can subtract a squared from both sides of the equation to get b squared on one side of the equation alone. Our equation is now b squared equals c squared minus a squared. If we substitute our measurements of 4 meters for c and 2.8 meters for a into the equation, we are getting closer to solving for the length of our side b. To do so, we need to square 4, which gives us 16, and then square 2.8, which ends up being approximately 7.8. 16 minus 7.8 equals 8.2, and so we know b squared equals 8.2. Now, to change b squared to b, we have to take the square root. So we will take the square root of both sides of the equation, resulting in b on the left side and approximately 2.9 on the right side. Now we know the length of our side B. It's 2.9 meters.
Great example, Jenna. As you can see, without the Pythagorean theorem, the construction of this house wouldn't have been possible. Thank you for tuning in and learning about Pythagorean theorem. Until next time, I'm Jenna.
And I'm Molly.
Good night.